Welcome back, everyone. Today's mini lecture will be focused on data analysis and graphing our data that we collect on target behaviors. I've identified our learning objectives for this week. So once you complete all the asynchronous activities and attend our class meetings, our goal is that you will be able to identify different components that are required for a basic line graph. You'll be able to explain and justify the purpose of making graphs, and you'll also understand how and when you might need to transfer your data to a graph and how you might need to convert your raw data into something that's usable before you graph it. All right, so let's go ahead and get started here. So graphing allows us to take a summary of all of our data and put it into a way that is easily readable for our users. Okay. Oftentimes you've probably heard this expression that a picture says 1,000 words. It can be quite overwhelming to just look at pages of raw data. But then when you consolidate that data and summarize it in a visual graph, it makes it a lot more comprehensible and digestible for other teachers, for the students themselves, and their parents. Right? And it's another way to help facilitate that communication between what the student is working on and how they're progressing towards their objectives. So that way everyone is on the same page in terms of whether or not the student is making adequate progress, or in the case if they're not, we all understand what the data looks like. So if we need to change our instruction, we have concrete evidence to support that decision. Right. So let's compare this. So this is just a small amount of data, right? But if you look at the left side, in which you just have your raw data, so it lists the days as well as the number of times a student is out of seat. That is our target behavior. You look at the numbers, and you might be able to get a sense that the number of out seat behavior, the frequency of it, is decreasing over the course of the week. Now that's relatively easy for us to see because there's only 5 data points in this table. But you can imagine that if you had 20 data points, 30 data points, it might be overwhelming and you might not be able to see the patterns if it's just in the table format, compared to if you put it into a simple bar graph. So again, it's the same data, but just presenting it differently allows us to see the patterns much more explicitly. And this is especially important when we start collecting a lot of data. Right? One type of graph that is very common in applied behavior analysis, and that is covered in your chapter, in your textbook, is the use of line graphs. So line graphs are most appropriate to show what we call continuous data. So data that is collected over consecutive days that might be related to the data the day before them or the day after them, right? In any line graph, we want to make sure that we are including the essential elements that will allow us to read the line graph. So again, we need to keep in mind that it's not only us who are using the line graph, we might share this data with other teachers, with the parents, and so by labeling your line graph correctly, it eliminates the need for you to explain unnecessarily. They can look at the line graph and know, oh, on the horizontal axis, also known as the abscissa, or x-axis, is the day of the week, right? And a user knows that because you clearly labeled it, saying day, right? The y-axis refers to out of seat, and specifically we're looking at number, so the frequency, right? And this is really important because without this label, I don't know what these data points refer to. And if you put just out of seat without the number, I wouldn't know if this is, amount of time, are these minutes out of seat, duration, I don't know, right? So that's why labeling is really critical and oftentimes an overlooked step by teachers. But in order to communicate our results effectively, we want to make sure that our line graphs are appropriately structured and appropriate labels. So the main components of a line graph include the x-axis, also referred to as the horizontal or abscissa, and the y-axis is their vertical axis. And that's also referred to as the ordinate axis, vertical axis. All right. In general, we put our dependent variable or the behavior that we're interested in, right? That goes on to the y-axis. The independent variable, or what is held constant, is put on the x-axis. So the data that we do not have control over. We don't have control over what day of the week it is, but we are trying to impact out of seat behavior. So in this example, day of the week or session is our independent variable. Out of seat is our dependent variable that we're trying to change. Okay. So we talked about labeling, right? So the ordinate label or y-axis label, okay? Our y-axis line here, right? Again, you could think of, to help you remember what's y-axis or x-axis, think y refers to yes. If we're going to use a nonverbal gesture of yes, we move our head up and down, right? So up and down refers to the y-axis. No, you might think of as x, right? So left and right, right? So x-axis refers to the horizontal, right? So in any line graph, we're going to have a y-axis as well as a label, an x-axis, and a label for the x-axis, right? We have the data path, so that's simply the line that connects the data point, all right? If for some reason you're not able to collect data, so again, this is continuous data generally, but you see on day 7 here, maybe the student was absent or the teacher just wasn't able to collect data, we want to indicate that there was a break in the data collection. Because up until this point, data was collected every day continuously, but we're going to indicate that we took a break on the 7th day through these series of parallel lines. Okay, right. Of course, the circles here, the closed circles, refer to actual data points. And G is referring to the abscissa here. So again, the basic components of a line graph. Another kind of graph that you may see in your textbook or that may be useful to you depending on what your behavior is what we call a cumulative graph, right? So with a cumulative graph, we're interested in how things are accumulating. So over time, how much is going on, right? So we're not interested in how much is happening in a given session or in a given day, but over time, how are they doing, right? So this might be appropriate for, let's say we have a goal for number of pages read. So my daughter right now is reading one of the biggest chapter books that she's read, and she's really proud of it. It's a 250-page book, right? So for her, she has a goal that she's going to read a certain amount each night, right? But what's most important is that she is reading more and more and more over time, right? So eventually, she'll read all 250 pages. So in this case, if we were going to collect and graph her data, a cumulative graph may be helpful and may be more motivating to her because she can see how much she has accumulated over time, right? So on Monday, maybe she just read pages 0 to 15, right? And then Tuesday, she read through page 30, then page 45, page 75. So you can see how it's growing over our time. So, but instead of starting back at 0, so instead of saying, well, she read 15 pages Monday, 15 pages Tuesday, 10 pages Wednesday, instead we're going to show how she has read an overall number of pages and how that's accumulated over the course of a week. So cumulative graphs tells us how much have you done so far, okay? So with cumulative graphs, your graphs, then the line, the data path, should always be moving upward, or at the very least, if there's no progress, it's a flat line. It should never be decreasing, right? You don't take away anything. You simply are adding to the previous day. All right, so here's an example of a cumulative graph. So again, we have our x-axis here. This is the day. So it looks like we start off at 0 through day 140. Our y-axis refers to the cumulative mileage. So we're looking at how many miles we're putting on a car, right? So we have a brand new car. We drive it out of the dealership. By day 20, we put on about 300 miles. By day 100, we put on 1,800 miles. So you see that the graph is always increasing, okay? And our interest here is not how many miles we're driving a day, but overall, how many miles are we putting on our car? Right. You may also be interested in doing bar graphs, right? Bar graphs are a way to represent occurrences of the behavior, right? Across sessions, across days. Each bar indicates one observation period. Okay. It's useful for displaying data on several students. So maybe you're tracking multiple students per day, right? And bar graphs may be one way to look at it when line graphs get a little too chaotic or cumbersome. Okay. And again, the purpose of it, like all graphs, is to provide a visual summary. of how your students are performing on a given behavior or a given skill, right? Again, here is a bar graph. This is actually from last year's class. This is how they performed on their quiz number 5. So you see on the x-axis here, I put the question. So there were 5 questions on the exam, and then I put, it actually should only go to 100%, so I should have modified my y-axis here because there's no such thing as 120% on this quiz, right? So the upper limit should have been 100%. So I apologize for that error. But essentially, I graphed the percentage of students who provided a correct response on a given question, right? So question 3 was a really well responded to question. 100% of my students got it correct. Question 4, 60% of students got it correct. So when I look at data like this, I can use this to inform my decision making. This tells me that question 3 and 5 was well understood and well covered by the readings in our lecture. But question 4, I would look at a little bit closer to see what is it about question 4 that is throwing students off. This would indicate to me as an instructor that I need to teach the content that was addressed in question 4 more thoroughly or provide answers to that topic. Okay. All right. Now I mentioned that sometimes, depending on the nature of your data, you might have to do what we call a conversion to make the data make sense in a visual format. All right. And this depends on the type of measurement recording you're using. Now with permanent products, these are things like worksheets, right? Like grades on a project, okay? Normally you can just report the actual number of occurrences or the actual raw data if the number of opportunities to respond are constant. So let me explain that. So let's say you have students who are completing a weekly test, right? So it's a worksheet of 10 math problems, and you're having students do that every week. Right? But let's say in week 1, there are 10 problems. Week 2, there are 15 problems, right? Week 3, there are 10 problems. Now you can see that reporting just the raw data may not be meaningful or may be misleading because 10 out of 10 on week 1 is all correct. 10 correct on week 2 is only 75% correct, right? Because there were 15 problems. So if the number of opportunities varies, you do have to convert it to a percentage, right? So I would say on week 1, they got 10 out of 10 or 100%, so I'd graph 100%, right? Week 2, they got 10 out of 15, which is 75%. Okay, so I can't just report the raw number correct in that case because the number of opportunities vary. Right. Now, if the number of opportunities were kept constant, so if the worksheet was always out of 10 points, then you could definitely just graph the raw data because the number of opportunities are held constant. Okay, so you have to consider that when you're graphing your data because you don't want your data to be misleading. Okay, same with event recording. All right, so let's say that you have a goal where a student will greet his teacher at the start of the day every day of the school week. Okay, so but let's say that on Thursday the teacher is not there, right? So the child does not have an opportunity on that day, right? So in that case, we would need to convert that to a percentage, right? So if he greeted the teacher 4 out of 4 times, that's 100%. Right? Okay. Right? Event recording, if you're using event recording to report rate, you might need to convert it as well, especially if the time varies, right? So let's say we are looking at number of pages read per minute, okay? So if if each time you are just looking at 1 minute, right? You could just report that number that he read 2 pages per minute, okay? But if that time varies, so let's say we didn't look at just 1 minute intervals, but one day we looked at his reading rate for how many pages he read in 3 minutes, right? We can't compare 3 minutes to 1 minute. You'd have to convert that 3 minutes to a rate. All right. Now this is covered in your textbook, so I won't go over all of this, okay? But please make sure that you look at this closely in your textbook and we can discuss this during our class meeting if there is any confusion. But the general rule of thumb is if the number of opportunities or if the session in which you're observing varies across days, you have to convert your data in order to compare progress across days. Okay. Now, if the number of opportunities at the time remains constant each time you observe, I observe for 5 minutes and only 5 minutes, then you can just graph the raw data. All right. So we went over this a little bit. Permanent product, again, in order to help communicate the student's progress, we want to make sure we convert it to a graph. Again, it could be the actual number of items if the number of opportunities are constant, right? So in that example of a math worksheet, if it's always out of 10, you can just then report or graph the number correct, right? Otherwise, you're going to have to report a percentage. Okay? Calculating percentages are really straightforward. Okay? The numerator is always the number of correct responses or a number of behaviors that you see, divided by the total number of responses or total number of behaviors plus non-behaviors. Okay, so number of correct behaviors over total number of responses times 100 will give you your percentage. Okay, so in this example here, I'm going to need to calculate a percentage because you see that the number of opportunities varies. It varies anywhere from 5 to 50. So graphing just the correct responses is not meaningful in this case and would be misleading. Okay, so in this case, I do have to convert to a percentage. So on day 1, this would be 15, right, over 15 or 100%. Okay, the second time would be 10 divided by 20, which equals 50%. Right, so you just take the numerator divided by the denominator times 100. All right, this should look somewhat familiar to you. This is an example of an interval recording data sheet. This was momentary time sampling. To make this meaningful, as you had practiced doing last week, you would convert this into a percentage of intervals, right? So X refers to the behavior occurs, 0 means the behavior did not occur, right? So to convert this to a percentage, I would take the number of X's, right, or the number of behavioral occurrences, divided by the total number of intervals observed, or in other words, occurrence plus non-occurrence times 100. Okay, rate is really similar, right? So again, you're taking the number of correct over the unit of time, okay, because the time here varies. Again, if the time was the same, it would be fine to just graph the number completed. But because the time here varies, I'm going to have to convert it. Okay, so this would be 20 divided by 15. Okay, and that would give me an overall number of behaviors that occurred per minute. All right, so hopefully that is helpful to you. Your book will talk about these concepts in much more detail. Make sure you keep note of any problems or questions that you want to talk about during our class meeting. In preparation for our class meeting, you will have to read chapter 5 of your textbook, and that will be the reading that you will write your discussion role on. And there's also an additional article by Aaron Barton, and this is more of a practitioner step-by-step of how to graph, which is something that you will need to do for your assignment 1. Okay, assignment 1, as a reminder, is on measurement and data collection. It is due October 8th on our Canvas site. All right, and as always, before our class meeting, please submit your discussion role and complete the weekly quiz. All right, thank you all so much. I will see you in class next week. Bye.